Wagwan everybody, it's your boy Mr. H again. Today we have a question of kinematics, and here the question asks: an automobile of mass 1450 kilograms accelerates at 1.6 meters per second square when 3.2 into 10 to the power 3 newtons of force are applied by the wheels to the roadway. So part 1 asks what force of friction opposes the car's motion. Okay, so that means we need to find what is the frictional force. Now we know that it is accelerating at 1.6 at 1450 when 3.2 was applied, right? So then we can say that my force applied plus my force of friction would be equal to my net force, right? Okay, so my applied force is going to be 3.2 into 10 to the power 3 newtons plus my force of friction times my F net, which is just going to be equal to MA, or in other terms, I can just say it's 1450 times 1.6 meters per second square. Okay, so then force of friction would be equal to 1450 times 1.6 meters per second square minus 3.2 into 10 to the power 3 newtons. Okay, so here I get the answer of force of friction is equal to negative 880 newtons. Okay, this negative sign indicates that the force of friction or the direction is opposing motion. Okay, so that means it's correct. So then we can say the force of friction is going to be 880 newtons against, I can't spell against. I don't even know if that's correct. I'll just put an arrow there. Friction of 880 newtons against the motion. So in my case, I'll just say towards the left. Okay. So part 2 asks if the automobile accelerates from rest for 8.2 seconds, find its final speed in kilometers per hour. Okay, so I'm just gonna erase this and I will show part 2. And so part 2 is, so exercise from rest. So we know that u is equal to 0, which is your initial. V, the final velocity we have to find. Okay, we have acceleration, which is given as 1.6 meters per second square. And we were given the time, which is 8.2 seconds. So here we will use one of the equations of motion, which is equal to V is equal to U plus AT. And then this is going to be equal to, so the U is 0, so that goes away, and that'll be 1.6 times 8.2. That's equal to 13.12 meters per second, or in terms of kilometers per hour, that's about 47, write that out correctly, 47.2 kilometers per hour. All right, hope that makes sense as well. And yeah, the equations of motion are just something we all will have to memorize regardless. The 5 equations of motion will come very handy, especially in this question actually. So the next question asks, what is the kinetic energy? What is the kinetic energy of the automobile at this speed? So we know kinetic energy is equal to E is equal to half mv square. Now, remember velocity, we like to keep it in meters per second because those are the standard units, not kilometers per hour. So in the previous question, we found it in meters per second to be 13.12. So all I'm going to say is half times 1450 times 13.12. Kinetic energy is equal to 124,797.44 joules. Or in other terms, I can say 1.25 into 10 to the power 5 joules. Okay, simple as that. It's not too difficult. And then we're moving on to how far does the automobile travel during this acceleration? So to find out the distance at which it traveled, we have to use another equation of motion. So we need to find s, or the distance, delta d. We know that what my acceleration is equal to 1.6 meters per second square. I know my time was given to be 8.2. So what I can use is equal to S is equal to UT plus half AT squared. Now U is 0 because that's the initial velocity. So then this whole term goes away and I'm left with half times 1.6 times 8.2 square. All right, and so just plug that all into a calculator and your result will be 53.8 meters. Hope that makes sense as well. Lastly, we will work on question number 5. I don't know why I didn't change the triple I's over there. What work is done by the applied force in accelerating the automobile? So what work is done? So we know that work is equal to force times displacement, or delta D, right? Or displacement, whatever. And so the force applied was given part one, or in the question itself, sorry, as 3.2 into 10 to the power 3 newtons. Okay, this is, remember, this is force applied. Okay, because what said, work done by the applied force, not by net force, not by friction, not by anything else, the applied force, which is 3.2 into 10 to the power 3 newtons. And we know the distance which we just calculated was 53.8 meters. So the resulting work would be 172,160 joules, and so I'm just going to simplify this as 1.72 into 10 to the power 5 joules. I hope this makes sense. If you all have any other questions, please leave them down in the comments. Or if you'd like to see some other kind of videos or just a simple question, just shoot them to me like, hey, I need to know derivatives. I need to know this, or can you explain this, or chemistry even. I'm more than happy to help, and I'll see you on the next one. Peace.